Hey everyone, welcome back to a new video, and today we will be doing a work example of the alpha beta pruning. Now alpha beta pruning is a more optimized way of the Minimax algorithm which we have for our game playing problems. So before moving on to the example, we need to see some things regarding the alpha beta pruning. Just like Minimax algorithm, we have a maximum and the minimum one, with the root being the max node. And the default values for the alpha values is in negative infinity, and for the beta it's considered positive infinity. The second thing is that the parents will be checking the current value with alpha and beta. So the max node will be checking the maximum between the alpha and the current value, and the minimum node would be checking the minimum value between the beta and the current value. And thirdly, we have the condition for pruning, that is, we prune when our alpha is more than the beta or equal to it. So keeping these rules in our mind, let's begin with the work example. So here we have a tree over here, and we will start solving it in a step-by-step manner. So we always start with the root first. So here is our root node, and this will be the max one. So we can say this is the max, then this whole will be the minimum, and then we will have the max here. So starting off with this, we have the default values for the alpha and the beta. So this would be alpha equals negative infinity, and we would have the beta as positive infinity. Now we start solving it from the leftmost side. So this is the parent now, and its values will be transmitted to its child. So over here, this node would also get the same values. It will get alpha as negative infinity and beta as positive infinity. Similarly, we go down to its children, and over here we once again start with the leftmost side. So here we have the alpha as negative infinity and beta as positive infinity. Now this is a max node, so the values would be considered, the values which would be the largest ones will be picked over here. So the max nodes go with the check that they have to pick the value which is the maximum between the current value and the value of the alpha. So over here we can see alpha is at negative infinity. Now 12 is the current value. So if we look, the max value between 12 and negative infinity is going to be 12. So here we have alpha as 12, and then we check with 16 or 12. Then we have 16 as a larger value, so alpha would become 16, and then it's checked between 16 and 0, and 16 is a larger value, so here we have the final value as 16. So 16 is the value of this max node, and the value of alpha would be 16, and the value of beta would be positive infinity. Now this 16 is the current value, and the current value of the child will go to the parent. So 16 would go to the parent. And now at the parent node, what we have, it's a minimum node, so it would be a min between the value of beta and the current value. So it would be current value and the value of beta, which is going to be positive infinity. So it is 16 and positive infinity, which is the minimum value over here. It is 16. So over here we have beta as 16. So for this parent node we have negative infinity is alpha and 16 as the beta. Now these values would go down to this node. Now when they come down to this node, we have the alpha as negative infinity and beta as 16. And over here we will check, since it's a max node, we would check the values for the alpha. So minus 18 is bigger than alpha, we would have minus 18 here. Then minus 15 is greater, and minus 5 also. But since minus 5 is the overall larger value over here, we have the end value of alpha as minus 5, and beta remains the same because this is a max node. So this would become negative 5. Now this is the current value of this node. So this would also go up to its parent. So now the original value of the parents was the current value of the parents we have right now is alpha is at negative infinity and beta is at 16. And now we are getting a current value as negative 5. Since this node over here is a min node, then it would undergo the same minimum it would undergo the same check of min between the current value and the beta value. So now we have the current value as negative 5 and we have the beta value as 16. So if we see the minimum between these two, we get negative 5. So this ensures, so this changes the beta value to negative 5. And now these values go down to the third child over here. So the third child over here will have alpha as negative infinity and beta as negative 5. So now the alpha would be changed because it's a max node. So it's between 9, 1 and minus 2. First let's check for 9. So is 9 greater or negative infinity? It's obviously 9. So we have 9 over here. Now we will check the pruning condition. We have to check that at every node, but over here we are fulfilling that condition, so we'll see how it works. So the condition is the alpha node has to be greater or equal to the beta node. So previously in these cases we had the beta nodes as positive infinity, so it's not possible to have a value greater than positive infinity, but here we have beta as minus 5. So we have alpha as 9 and 9 is greater than minus 5. This means that this would become 9 and these both would get pruned. So you see, when they are pruned, it makes it efficient because the algorithm does not have to search again for these two nodes because the values they contain are 1 and negative 2, and both of those values cannot be greater than 9. Now we have these two nodes getting pruned because they fulfill the condition. Now for this specific node we have alpha as 9 and beta as negative 5. Now these values would go up, the current value over here, and it will be checked with the min value over here. So it's minus 5 over here and beta already has a minus 5. So for this specific node we have the value as negative 5, and the values which we had of alpha and beta were alpha as negative infinity and beta as negative 5. Now this being a child will send its current values to its parent node. So its parent is over here and that's a max node. So the current values which it has is negative 5. So this negative 5 is sent over here. And what will be done now is a comparison between the max value and the current value. So over here if we see, we have the max value as negative infinity and the current value is negative 5. So it's between negative 5 and negative infinity, for which minus 5 is the greater value. So the alpha value gets changed to negative 5. Now this is the value of the parent and it will be sent down to its child. So we start in the leftmost manner, so the value gets sent down here. Here we would have alpha as negative 5 and beta as positive infinity. So from here we have the value sent to its child in the leftmost fashion. So once again we have alpha as negative 5 here, beta as positive infinity. Now here it's a max node, so we are going to compare the values of these three with the values of minus 5. So 1 is the largest value over here, so we get 1 over here. Now can we prune this? The condition is alpha has to be greater than beta. So here we have alpha as 1 and beta is positive infinity. Since nothing is larger than positive infinity, we cannot prune them. Next we check minus 12. So is minus 12 greater or 1? It's 1. And then minus 15 or 1? It is 1. So the value for the node ends up being 1. Now this is the current value of 1, so it gets sent to its parent. Now the parent is a minimum node, so the comparison over here would be the minimum one between the current value, that is 1, and the beta value, which is positive infinity, and the beta value, which is positive infinity. So here, if we see the comparison, it is going to be between min, the 1, and the positive infinity, and the minimum value over here is 1. So this gets changed to 1. Now these values would be sent down over here to the second child. So here we have alpha as negative 5 and beta as 1. So negative 11, is it larger or negative 5? It is negative 5, so there is no point in changing the values. Then we have 6. Is 6 greater or negative 5? It's obviously going to be 6, so alpha becomes 6. Now let's see the pruning condition. Pruning condition is alpha has to be more than the beta value. So here we have alpha as 6, beta as 1. So the condition is being fulfilled. So since this gave the 6, this will not get pruned because this gave the value. Instead, the next one would be pruned, and that is this 1. So this gets pruned, and it makes sense because 6 is already larger than 1. There is no point to check 1. So this value gets pruned. Now we have alpha as 6 and beta as 1. So the current value here is going to go up, and then the comparison will be done. So here the beta value is 1 and it's 1 over here. So over here we get the same values, alpha as negative 5 because these were the values of its parent, and beta as 1. So negative 13 or negative 5, negative 5 is greater. 11 or negative 5, 11 is greater, so the value of alpha gets updated. Now alpha is 11, so is 11 greater than 1? Yes, it is. So this fulfills the condition for pruning, which means 2 gets pruned because there is no point to search that since we have 11 and it is already larger than 2. So now we have this value as 11 and the three values for the children are complete. So let's go back to the parent, and there is no value which is smaller than 1 over here, so we get the beta value as 1. So now this child is complete in its value and its current value is 1. So this 1 will get sent to its parent, and this is a max node. So it will compare the current value which it has, that is negative 5, with 1. So the comparison would be max between negative 5 or 1, and the max value over here is 1. So this becomes 1 and alpha over here also becomes 1. So now we have the root node as 1. Now this will send its value to its child over here. So this child will get alpha as 1 and beta as positive infinity. So this will send those values to its leftmost child. So alpha as 1, beta as positive infinity. Now over here, alpha is 1 over here, so negative 4. Negative 4 is not greater than 1. Similarly, negative 13 is not greater than 1, and negative 2 is also not greater than 1. But among these values, we have negative 2 as the largest value, and since it's a max node, it has to pick the largest value. So we get negative 2 over here. Now this negative 2 is the current value, and it gets sent to its parent. So its parent is a min node, and the min node has positive alpha as the value of its beta. So we are going to see what is going to be the min between negative 2 and positive infinity. So it is negative 2. Hence this beta becomes negative 2. So this child will get alpha as 1 and beta as negative 2. So over here, if you see, this is fulfilling the condition of pruning, which is alpha is greater than beta, because 1 is greater than -2. So this entire child and his children, they will get pruned because it makes no sense to search for them. And just like that, we have the same values going to the right child, and they will also get pruned because the alpha is greater than the beta values, which will leave this node value as to be -2. So this is the current value of this node, and this will now be sent to its parent over here, and the parent's current value is 1. So if we check the max between the current value, which is -2, and 1, we have 1 as the larger value here. So with the final value as 1, our alpha beta pruning example is complete. So just as a recap, remember, we have to look at the nodes first. Is it a max or min node? Once that has been sorted, we have to look at the current value, and we have to compare that with its corresponding alpha or beta value depending on which node. And the parent will always send its alpha and beta values to its children, whereas the child will only send its current value. So for more practice, you can visit this site. I will be attaching the link in the description box. So over there, you can have your own examples with different depths and branching factors, and you can also have your solutions generated. So that's quite helpful for your practice. So I hope you enjoyed this video, and I'll see you in the next one.